Hi everybody and welcome back to our lecture on Solvency II. So in the first video we covered what Solvency II is at a high level and then talked about how we used to do reserving or working out the balance sheet for an insurance company under old style regulations that applied before Solvency II came in. What we're going to do in this video is go through the Solvency II approach, so you can see how it's different to the old style approach, and then talk briefly about what this means. So let's kick off. So our title here is Solvency II approach. So we're going to draw another one of these balance sheet diagrams. So this first box I'm going to call market value of assets, and this over here, let's draw in another rectangle and break it into two. This thing here I'm going to call SCR, and this thing down here market value of liabilities. The SCR stands for Solvency Capital Requirement. And so the difference between these two is our free assets. So we need to calculate market value of assets, this SCR thing, and the market value of liabilities. But let's define these. So where MV of A is equal to, by definition, market value of assets. The MV of L is equal to, by definition, market value of liabilities, and the SCR is equal to, by definition, Solvency Capital Requirement. Let's just define this a little bit more. So this is equal to the amount of money required, so MV of A is greater than or equal to MV of L with a 99.5% probability in the next 1 year. So if you've done ruin theory in your in some of your previous mathematical courses, this is kind of very much what this is. You're holding an amount of money that prevents the company from being ruined, in a sense, or becoming insolvent over the next 1 year, and the amount of money is big enough so we are 99.5% sure that that's going to be true. So key things are market value of assets greater than or equal to market value of liabilities, 99.5% probability in the next 1 year. And this is where all of risk is contained in some sense. So if we take on more risk, then it means that we're going to have to hold more money so that the 99.5% probability thing remains true. So basically, if we take more risk, this SCR thing gets bigger. If we take less risk, then this SCR gets smaller. Okay, so this fixes the old problems. Market value of assets is closer to what we expect on sale of assets. I'll just put something into brackets, but is always out of date. So if you remember, with the old style reserving, we had a discounted value of assets here. And that's not the amount of money that you're going to get when you sell. And what you're going to get is the market value. So we put a market value of assets here. So this is much better than what used to be here. But this market value of assets is only true at a particular point in time. So we get it from the market on at a particular time, and then one day later it's out of date. If we sell all the assets a day later, we'll actually get a different amount of money to what's here. So it's better, much better, but it's not perfect. And then prudence is very clear in size of SCR. So if you remember before, down here we had something called a prudent discounted value of liabilities. And what does prudence mean? Prudence might mean a different thing for one actuary compared to another actuary. So one actuary might make their QX for mortality bigger by 20%, and then another actuary might make their QX for mortality for a different company bigger by 30%. So it's not obvious how safe the discounted value of liabilities is. Market value of liabilities, if you can get that number, is defined by the market, and then all of the prudence is in here. So if we're taking on more risk, then this gets bigger. If we're taking on less risk, then this gets smaller. But this is your safety net or your safety margin. The market value of assets could drop below the level of the SCR, but still be above market value of liabilities, which is what you expect to need in order to pay claims. So this becomes very clearer. You can see if one company has a bigger SCR than another company, or one company has a smaller SCR than another company. However, although we're fixing some of the old problems, we do get some new problems. This bullet should have been slightly. Can I move this? Let's see if I can quickly move this. This might go wrong. Let's do it again. Okay. Can't remember how you do the moving thing. Add, replace, remove. Okay, I'll fix it afterwards. Okay, so let's switch that off. Okay, so new problem is market value of liabilities is hard to get for many liabilities. fix this by setting market value of liabilities equal to BEL plus risk margin. So for most of your liabilities, this is the calculation you use. Instead of having a market value of liabilities here, you have two pieces. Now the market value of liabilities is easy to get from the market for some liabilities. So for instance, if you've got a guarantee that behaves like an equity put option in the market, then you can get the market value of that guarantee from the market and you just slot that in here. But for lots of actuarial liabilities, those numbers just do not exist in the marketplace. So we need to use this equation instead. So this BEL stands for best estimate of liabilities, and this thing here is called the risk margin. Okay, let's define these two things a little bit further. So let's go up and give ourselves a bit more space again. So BEL is easy to calculate. BEL is equal to gross premium reserve for all cash flows for a liability calculated using best estimate assumptions and risk-free interest rates. So it's a gross premium reserve for all cash flows for liability calculated using best estimate assumptions and risk-free interest rates. So as you can see, there's no prudence in here. Okay, so again, different to the old style approach. This is a best estimate reserve, best estimate assumptions and risk-free interest rates. And then the other piece is the risk margin. So keep putting my bullets in the wrong place. So risk margin, RM, is easy-ish to calculate. So here we get a formula. So the risk margin is equal to 0.06 times the sum, it's a bad sum sign, from t equals 0 up to infinity, the solvency capital requirement at all times t over 1 plus risk-free rate t plus 1 to the power t plus F1. The complexity here is that we need to know future SCRs, but this can be approximated. So what is the point of all this? So what we're trying to do is mimic the market value of liabilities. So that's the piece that we want to have here. And instead, we're splitting it into two: a best estimate liabilities plus a risk margin. The best estimate liabilities is just a gross premium reserve, discounted using risk-free interest rates. In fact, these risk-free interest rates are the same things as these. Discounted using risk-free interest rates, best estimate assumptions, so it's standard reserve. But if somebody was to take on this liability, was to buy it from somebody else, they wouldn't just hold a best estimate liability. They also have to put money into an SCR as well. And putting the money into the SCR, they kind of expect that they won't need to use the SCR and they'll get the SCR back in the future. So this SCR money just goes on in for a bit and comes back out for a bit. But that additional cost to the person who's buying the best estimate liability means that they would demand to be paid more for it. So if you like, this BEL is not big enough to represent the market value of liabilities. It needs to be increased. And that's what this risk margin formula is supposed to do. It's supposed to add on an amount of money that represents, in some sense, the cost to the person who's taking on the liability of putting the money into the SCR for many years into the future and then getting it back. And that cost is what's represented by this 0.06 figure. It's just a formula. That's really all you need to know. It's a complicated formula because it uses future SCRs, so in theory you have to work these out for many years into the future, but there are rules in the regulations that say that this can be approximated. And also this formula is what the European Union uses. In the United Kingdom, this has been changed recently, so the 0.06 has become smaller. I think it's maybe 0.04 now, and the SCR bit at the top, this formula has changed slightly. Basically what the UK is trying to do is make this risk margin component smaller so that companies in the UK don't need to hold as much capital for certain kinds of risks. Okay, good. So that is basically the Solvency II balance sheet. So what does this mean? So the question is, what does this mean? Answer. Take on more risk implies that the SCR goes up, but then that implies, because of how the risk margin formula works, that the risk margin also goes up. So both of those things go up, and that implies that your free assets go down. So this whole thing implies companies are incentivized to reduce risk, comma, or at least think about how much risk they are taking on carefully. So you would kind of think that any reserving regime would do this, but actually the old style one didn't do this so much, whereas the new style one definitely does. If you take on more risk, you have less free assets. If you take on less risk, you have more free assets. And companies want to be financially strong. They want to have more free assets. Or, if you like, they think really carefully about whether they take on more risk, because they know more risk is going to reduce the level of their free assets. But maybe they want to do that. You know, you make money by taking on risk. You increase your expected profits by taking on risk. But that's a judgment call, you know, to do with how you run a company. How much risk are you willing to take on? Okay, that is a good place for us to stop. So over the course of these two videos, we've covered Solvency II as an overview, the old style way of doing things, the kind of new style way of doing things, and then what does this mean?